So there is a chance I get stuck and I might have to just spend a bunch of time thinking. So, but I have one thing that I have in mind to try, and I didn't try anything since last time. So I'm just gonna continue to try to implement the Barnsat algorithm or solver. So one thing that I realized that I was doing wrong, and because I forgot, it has been a long time since I haven't done anything with recursion, but you have to pass the nodes on the tree, because then obviously, regardless of what you do inside of the function, it's just going to generate an infinite loop, because there is no traversal in the tree. So I'm going to have to change the function so that I pass the nodes, and then the traversal happens by each time you call the function recursively, you pass the children, the left and the right. So the one thing that I'm gonna see is whether or not you can, because I'm not 100% sure if you can pass the object that is calling the function as an argument to the function. So if I make the function as part of the root nodes or as part of the node, then will I be able to call the function from the root and then pass the root? Or if it makes more sense to make the function as outside of the class and then just pass, or outside of the struct and then just pass the struct. It's just small details. So I'm just gonna change this. So the first thing that I'm gonna try, and if it doesn't work, I'm gonna have to spend time thinking about it, like I said. But I'm going to create another flag variable. It's very confusing to think about. I'm gonna have to read the stuff that I have there. But I looked into last time after I closed the stream, I just briefly looked into the other implementation, and it looks like the other one, they also ran into the same problem, which is when you have two nodes that want to occupy the same space, then you have to split the nodes, and then it becomes a problem because if you don't do anything, it's going to create an infinite loop on the recursion, because the two different nodes are going to keep falling to the same spot since they fall into the same space. So you have to force them to go to the subspaces. That's the issue. So what I thought about is just very simple. You just create another flag variable, and then I have to think about the name now, but the flag variable is going to indicate whether or not the space was disputed space between two nodes. And if it was, then I can change the flow there. So I can just skip the thing and just go to the children. And I'm thinking that it's probably better to just, whenever there's a dispute, I just immediately update the node that was the body at that subspace without having to call the recursion. I just assign. So I think the first thing that I have to clarify is this function here, because this is another point that is kind of confusing. is how do you divide the space? Because there's infinite amount of ways to, like, the amount of children that the tree has determines the amount of times you're gonna slice the original space, but obviously there's infinite amounts of ways that you can create a plane that is gonna divide a three-dimensional space. So I think ideally find a way that's always guarantee that the original thing that was there on the space is gonna fall on either one of the new subspaces that get created. Verify, that's whatever. Loop over all the nodes, call the recursive function. Not sure if I should pass like this. Is it necessary to create 3 forces, or is it possible to update forces at the same time? Check to see if PH3 node is a subspace and not a body. If it is, then the comparison of the current position will be against subspace and not its own space. What is the best way to subdivide a space? Check if children are currently new. Node doesn't have subspaces yet. If they are, call set subspaces to create the children. For each child of current 3 nodes, check if child subspace is marked as a body. If it is, then the subdivision will happen. Change nodes. Is body to false. Okay, so is either gonna be a subspace, which is this one, or is a body. So if the children are no as sets, create the subspaces. Check if new body is inside subspace 0 or subspace 1. I think it's probably better to put this inside there. Yo, thanks for the follow. Also, the other thing that I realized that I don't know why I didn't think about this, but is this condition here is that when I'm going to change a node that is a body, all I have to do is just create another variable, and then assign the previous body to that variable temporarily, and then I can make the other variable conditional, which is what they did here. And I check to see with ChatGPT, and it looks that there isn't a problem with C++ when you do that, because you're just reassigning pointers. So either here, I'm going to if I put just else here, then I have to guarantee when I split the space that if the node doesn't fall on one part, it has to fall on the other one. So it can't be in the middle. The position can't be on the plane of the intersection between the nodes. But I think that's probably not. Because the only way to guarantee that is if you do the subspaces based on the position. So I don't think I can guarantee that the points are never going to be on the intersection of the space. So I think I have to put else if, it's probably better, and then I just check to see if it is a part of the other space. And if it isn't, then I just recreate the subspaces, I think. The problem with recreating is that it might be very complicated because of the other, like there's a bunch of different situations. That's the issue. Because like the way you break down the spaces is going to interfere with all the children of the current space. So if I have to re-update, then I have to think about if there are cases where there's going to be children of the current space, and then I'm going to have to change all of them, which I think it doesn't make a lot of sense. This is another, I guess that here they use an RNG to do this, I think. Let me think of this. In what situations you're gonna want to create a subspace? I think the only situation is in the beginning, where you have the first node. But even in the beginning, so let me think about. So when is the root node? Yeah, it's the thing that I was thinking about yesterday, that if I don't want to check on the first one, I have to build on the constructor. Well, I think it don't. So the first one, I think you should always, like the default behavior should be to put the first node on the first space and then subdivide on the second one. So I think the only situations where you're gonna subdivide your space is when you have two different nodes that one should be on the space. So I think I have to subdivide based on the points. So, but there is different situations. So one situation is when you don't have Yeah, so I have to, I'm gonna, yeah, this, let me. So I can make it based on a flag variable. Because there, one situation is when you have this free subspace and you just want to put the body there. But if you have the free subspace, then you don't need to subdivide. That's the thing. But maybe in the beginning you need to. So maybe this check should be later. Yeah, but then it defeats the point of the other. Because I can't check if there are no subspaces. So maybe I'm thinking about it the wrong way. I think I shouldn't check on the subspace. I should check on the current space. That's the thing. So I think that this is probably wrong. So I have to check based on the. So first, if the current space is not a body, then it means that it is a subspace, obviously. So I have to check whether subspace is disputed. Because the situation that I was thinking about was about the levels. So I think that there can be situations where, and it's probably going to happen very often if the tree doesn't have a lot of children. So in this case, a binary tree, so it's going to have many levels. So I think it's going to happen very often, a situation where you're going to have two nodes that are going to break down the levels more than one time. So you're going to have situations where you have two different levels of the tree that only have subspaces. I think this is because it becomes a problem, because then you can check to see, you can check based on the children of the current node, whether or not you can make that subspace a body or not. Because I think that the definition of a node that is a body is that it doesn't have children. So like you can't have a node that has children. To turn that subspace into a body, because then it fucks up all the other children that the node would have. So if a node automatically, but this is the case, it might be the case that a node only has subspaces as children, in which case you could remove the children and just turn the node into a body. So the situation I'm thinking is, because this is a branch of the tree that is going to be a subspace for sure. So I think there's two situations. When is a subspace and the subspace doesn't have children, which means it's possible to put the new body there. So maybe I should check. Yeah, so I should check to see. First, check to see if it has children. Because if it doesn't, then automatically means that it's possible to put a body on the space. Yeah, so check to see if current space has children. This is like obviously easy to do. I'm just gonna put the equal. So when I set the subspaces, I'm gonna always set them at the same time, so I can check for the first one only. So if this is true, I think that makes it a lot easier to think about it this way, because it makes it a lot easier to always think about the level, to put the node in the same level, because then you don't have to think about the two sides. So I'm thinking about the function that subdivides the space is better if I accept either two nodes or one. So there are situations where I think that you have to accept only one position, because the subspace is not. Yeah, but this is the problem, because it's always gonna. I think the situation that is not gonna fit is when the subspace that has children. When the subspace, when the space has children. So in the beginning, obviously, because the first space is based on the geometry, all the nodes are going to fit on the beginning space. And what defines in which category they go, on the left and right of the binary tree, is going to depend on the subspaces from that space. So Yeah, but I think that this has to be based on the variable there. So it's based on the disputed. So the disputed variable forces the node to traverse the tree. And the way that I'm going to traverse is just by calling the tree recursively by passing the subspaces with the same body. So I think that I can put the condition here, because if it doesn't have children, then it only matters. So like what happens to node space that has points, new body, get position, what happens then? So it's a node and it has a position. I'm trying to think if it makes more sense to put this condition here or inside of the thing. Because I'm going to have to put another one, I think. So if it doesn't have children, then it means that a new subspace that can be used to put the body. Because it's not disputed, probably. Maybe I should put disputed as well. It's kind of hard to think about the conditions. But in this situation, I know for sure that I can turn the current space into the body. So, but what happens if you can't put it there? You're gonna have to check. Anyway, here. I'm gonna have to check again for the subspace. So I think it makes more sense to put this inside. But let me think about this. I guess the question is, is there a situation where the node, the space is not gonna have children, but the point is not gonna fit on the space? I think that it can't happen. It can't happen. Oh, I think that the only situation is when it is a body. So a body, it's possible that the body doesn't have children. So I think here I have to check whether or not this node is a true. Yeah, but it's already checking here. So this automatically means it's a subspace, so it's not a body. So if it is a subspace, and then I can always put the node here, because it has to fit. So if it doesn't fit, then something weird happened, I think. Trying to make sure, so I'm trying to think about whether or not this is really the case, because it does feel, if it's not the case, I have to think about a condition to put here, but I don't see, like, I'm trying to think about situations where it might not be the case. I think on the other ones, I have to make sure that whenever initializing a new subspace, because if it is a disputed subspace, I'm gonna create the subspace before I call the function recursively. So if the node is disputed, so if you have a situation where the current node's a body and the new body wants to be on the same space, I'm going to store the body on the variable of the node. Maybe I don't even need to store, I just split the space. Oh, but that is gonna depend on the way that but even if I do the way that, splitting the space in the way that I'm thinking, I can just split the space right there and then change the state of the node that was a body, should be a subspace, and then automatically create the subspaces as children of the current body, of the current node. And then after that, they call the function recursively. So this is going to guarantee that whenever it's a disputed subspace, it doesn't have children. It does have children. So I think the only situation where the children are null pointers are going to be on the beginning of the iteration, so the root node. So in the beginning, the root node is a space, and it doesn't have subspaces. So it means that the node should fit there, because otherwise something went wrong on the creation of the geometry. Yeah, but this might be the case, so I have to check, I think. So maybe I should throw an error if this happens. So I just check inside, and then I just throw an error just to make sure, but it shouldn't always... Because the only possible situation is when you want to put a body on the tree that is outside of the bounds of the space that was created based on the geometry. Because the root is always created based on the space of the root is always created based on the geometry, the minimum and maximum vertices. So we're creating a box that encapsulates the entire geometry. So if you pass a body here that isn't a part of the geometry, is going to... It might be outside of the space. So I guess I'm just going to put a check here though. After when I get the error message from in the global signals, just this one. This one there. So if that's not the case, then obviously it fits. So how do I turn the... I think I make... I have to split the space. No, I don't have to split the space, I just make this body equal to true. Then I assign the body to be equal to new body. I think this variable here is the one probably that I should remove, because I can check based on the spaces. Oh, so the other thing I have to do is the total mass and center of mass. So total mass is gonna be and the center of mass, it's the body mass times the position. Maybe I should do this I should do this before. Or divided by, I think it's divided by, no. I think if it is just a node, then it's just a multiplication. But maybe not actually. Yeah, so it has to be, I think, divided by the mass. I'm gonna do this on the beginning here of the function. I think that the position should be on the sphere, but I don't remember. Yeah, I'm not pretty sure if I did here get position. So I didn't do hardly. Because the position already exists on the sphere, I think. Also, I do have. Also, yeah. So I can put that position because it comes from the node 3D that the mesh instance 3D inherent from. So get position is probably gonna be on the node 3D as well. I got position, I got the mass, and then it's replaced. So the center of mass is just gonna be the position actually. Not multiply, but I'm gonna divide. I think it makes sense. I'm just gonna ask ChatGPT, but I'm pretty sure that this makes sense. So this is the least complicated. Oh yeah, the mass. The least complicated situation because it's just a body, so. The other ones are more annoying, but I think this function is probably correct. It just takes the position of the nodes and the mass, and then just adds to the total mass. Yeah. So this should be. The question is, do I think I have to return here? Because this is the end of the function. Because when you reach the limits, you just return. And let me. Yeah, so this situation is already, like, it is a space. So like when the first time that you add the roots, it's just gonna stop here because the body's gonna fit. So it is a space and it fits the thing because this is no. Oh, I have to. Oh no, this situation I don't have to create anything. So it's on the other situation where I think I have to check first if it is a body. So yeah, so check if it is a body. Because if... Oh no, but if it's a body, it's already there. So I have to check if it's disputed. Because those are the two situations when so maybe I don't need this other stuff here because this is gonna be on the other thing. Yeah, I'm gonna remove. I'll think about this. If I need there again, I put it again. But I think the only situation is when you have a new space and it doesn't have any children, which means that the node is gonna be inside, or you have a space that is already a subspace because of a previous dispute that existed. I think those are the two situations. So maybe I don't need the variable as well. But it's probably better to have the variable. So what happens if it is a disputed situation? So if the subspace is disputed, I have to check based on the children. So I have to check if the body fits. So now I'm gonna recurse. So check, just see if. The question is, when do I create? Which situations do you create subspaces? Oh. I think it's only when the node's a body. You just call the function recursively, and then you pass current nodes subspace 0. So maybe I don't need the other variable, just because this is already gonna track. So let me just make sure. So, and the problem is that there can be. Well, obviously, I'm just gonna test to see. But this is kind of the tricky thing. I'm gonna have to spend a bunch of time thinking about it to just see if it is correct, because even if it works, it might be the case that it fails. But I think that the complicated part is when the node is a body, because then the subdivision happens, and then I have to rethink whether or not it's necessary to have the disputed thing. And I have to think about how to make sure that on the subspace division, that it always divides the space in a way that the two different points are on different places. And if it is the same point, then what happens? And can you have a situation where I think if the points are the same, I guess, let me think. One way would be to just consider them as the same body. And then I would have to change the class. But I think I will think about this later, so it's easier. But probably the set subspaces function is gonna have to receive the two positions. So I think that it receives only one position, which is from the new body. And then inside of the function, it compares with the other as well. So if it is here, then it is a subspace. If it is here, is either the first time that you are running, which means that the node should be here, or it was a previous space that got split because there was a dispute, I think, which is the situation here. But I think that this is where the infinite recursion would be, because the point's always going to be the same. So I do need the other variable here, I think. Yeah, so if is disputed, let me think. This is, I'm not really sure if the flag variable solves the problem. Because like, how do I make sure? But maybe you don't need to, because it's already it's gonna go from the like, it's gonna go from the points of the children. That's probably that's the issue with the way that I was doing last time, because I forgot that I have to pass the node from the trees in order to be able to traverse. So like, if I'm starting from the child, then it's not gonna visit the same spot twice. And this already means that it is it might be necessary in this branch, but I think here is probably fine. Because even if it is but if it is, the problem is when you have a situation where you have, this node has children, so it's a space, but it has children, and one of the children is a body, so yeah, I can't turn this into, no, but then I keep traversing, I think, and it doesn't matter. Yeah, which is what I'm doing here. So I'm just checking to see which one it is which. Yeah, so I think this is fine. Now let me think about this other condition. So if it is a body, then it means, then I have to check. I check to see if the no, I don't need to check, because I'm gonna have to split, because the way that I'm doing now, like, the node's gonna have to fit on the space if it hits this branch. Because it's either, so I think that the easiest situation to think about is the beginning. So the first time that I call this function is gonna be with the root. So I put the root on the first space. So the root is initially space that doesn't have children. So it's gonna follow into this one, and then it's gonna become body, and it's gonna become, oh, so I have to make current nodes. So I can't change, because I'm always starting from the top of the tree. Yeah, so current is body. Because it has to update each time as well, anyway. So the first time is gonna follow here, which is gonna turn the roots of the tree into a body, and it's gonna store the information that you pass there with the node. Then the second time on the iteration, then it's gonna hit this branch here, because it's not gonna be a space anymore. and then it's gonna have a dispute anyway. So it means that the first time the two things are, so maybe I have to put the condition again, I think. Yeah, I have to put this condition because if the node doesn't, if it doesn't have the body position, then it means that there was something wrong, because on this part of the branch, you should, the body should, the new position should fit on the space, on this space here, I think. And then every time I'm going to have to split the current body into oh, I have to update the center of mass as well. This was another question that I had. It's like, how do you prevent the nodes from being, the center of mass from being added multiple times? And I think like here they are always increasing, which is a problem, I think. So maybe I can use the is disputed for that. So I'll only increase the center of mass if the node, yeah, but then it doesn't guarantee. Oh, so I think I can increase each time. Hey, what's up? I can increase each time based on the. So because I'm gonna update right away, I think. So instead of calling the function recursively for the current body, I'm just gonna split the space and then pass the body to the subspace. And then when I pass the body to the subspace, I add with that body. So the next time. So here, actually, I need to increase as well, maybe. I think. Oh, so here, yeah, here I have to call the function, I think. No, but it's like the subspaces should have the center of mass based on the children. So I think here, after I call recursively, I'm not really sure if that makes sense. So here is a space, and this is a subspace. This is not a body. So the question is, so here I'm checking just to I think it's fine to call recursively because it's gonna, next iteration is just gonna fall into this if it does fit the position. So the question would be, why not just set the, so if the subspace 0 has the body position, then why not set here? But it might be the case that the subspace is a body, but maybe you can check that. I think that's just easier to think about like this. And I think here I should probably, yeah, but this is the question. It's like, when do we increase the center of mass? Because I think you have to increase for the subspace, but because the subspace has to be, like, the representation has to be only for nodes that are children. But maybe, yeah, so when you traverse, it's not gonna hit this anymore, I think. Because on the next iteration, so let's say, for example, that this is not, so this is a subspace in this current iteration, so it's gonna hit this. And it's not the leaf of the tree, which would be this condition here. In which case, it's automatically gonna become a body. So this situation is when you have a subspace. So if you have a subspace, then you need to keep traversing, because it might be the case that the subspace has bodies as children. And I can check here, but I think it makes it more complicated. But if that's the case, then each time that you pass through the subspace, I think you should update. So it should update the center of mass and the total mass, because then it means that the node visited the subspace, and it's gonna be a children somewhere along the line. Because this is the base case, so it has to hit here. The only way to stop the iteration is to hit here, the recursion. Because you reach the leaf of the tree, and you have a body. And the node doesn't have children. So on the other ones, it's just gonna either split the tree on this thing here, to transform a node that was a body into a new subspace, or it's going to hit a middle subspace, let's say. That is this point here. So here is where you should update, I think. So just call, here, yeah, I have to change the function so that it accepts as well, because hey, what's up? A small PC. So just pass the current now. Body position, the body mass. I can update before, I think. Because it's going to be the same on both situations. Because regardless of which path I'm going to take on the tree, it's going to update the current nodes, because it's the current subspace with the body position, the mass. And here I have to change. Actually, it's here. Total mass and total mass. I'm not, no, I'm creating a graph on 3 dimensions. Someone's asking if I'm creating a game. Yeah, I think that's fine. So the question. So now let me think about this one. Split the current node with success rates is on the position. I have to change the. So I'm gonna ask ChatGPT. I'm just gonna copy this in the beginning there, and then I'll think about it. This is more like annoying than just annoying to figure out. I mean, I guess I don't need to return anything here, because I'm just gonna set the children instead. So I'm gonna change the void there. I'm just gonna think about here. I'm just gonna put the function and then I'll think about it later. Also, maybe I should put just current node, because I'm gonna pass the current node. Or actually, yeah, since I'm gonna be calling from current node, I can just do it based on that. So I don't need to pass the original space as well. I can just pass the new position. It's gonna be body position. And here, so can there be a situation where I'm gonna split? I think I'm always gonna split when the nodes are body. So the only situation where I'm gonna update is only knows the body, because that's the only thing that makes sense, I think. Because otherwise, you should just always take the current position. Yeah. Yo, thanks, man. Node space ensure choose subspace and initialize its children with each space based on the node's body position. Split the current nodes, create subspaces for it based on your position. Oh, then I check to see. Then I update the current. It's basically gonna be the same thing here. So, yeah. Oh. So the question is whether or not I need to increase the center of mass of the new one. I think I do. So I need to, of the current space has to be, so current node has to be, so increase. So I'll be right back, but I'm gonna do this. So I'm just gonna update the center of mass of the current one because it's transitioning from a body to a space. So it will for sure have the previous body that was at this spot as its child. So its center of mass should contain the body that I'm moving here. And I'm just gonna check to see based on the subspace 1. So if it doesn't fit on the subspace 0, then it fits on the subspace 1. But I think I'm just gonna put the same condition. So else if, and then puts subspace 1. And then just update as well. So I'll be right back. So actually, I just realized that I don't need to update here because if the nodes of body is already gonna contain the mass and the position of the current node. So the only place where I have to update is on this situation here, I think. So it's when a node is traversing through a subspace, because on the next iteration, so after the split, then I call recursively, I think, probably. Let me think about after this split, what happens. So now, so here is a body. So it's going to split, and then the current node is going to become a subspace. So the next iteration is going to hit here. And it's going to have children because it became a subspace. So the question is on the recursion if I call from the same level. Now, so let me think. Because if I split the current node and I put the body right away on one of the children, then do I have to, from the body that was supposed to be inserted, do I call the function recursively from the same level? I think that doesn't make a lot of sense. So if I know for sure that based on the way, this is kind of tricky because on the article it says that like there can be a situation where the space, where you're gonna have several different disputes because the nodes are on the same position, but I'm assuming here, based on the way that I'm going to split the space, is always going to be the division of the space is going to be done in a certain way that each node has to be on one subspace. So if I can guarantee this should happen, then I can always call from here recursively based on the children that the other body is not, because I know that the other one's going to be inserted there after. Or I can, yeah, ready. It's confusing because then why not just set the other one right away and just stop the iteration? So in what situation you can have several different disputes? And this is the question. Because it is based on the quadrants. Yeah, I think that's the difference. So I think that on the article, the way that they are thinking is based, like you have a fixed separation of space, but maybe this is the correct way to do it. So you have a fixed separation of space, and that's the reason why you can have several different disputes, because you're always dividing the space in the same way. So it can be the case where you divide the space and you still have the two nodes on the same subspace. But if you're capable of guaranteeing, or the function that subdivides the space, that you always have one node on either space, then it allows you to just return the function, because you know that. But then the question is, because like what's the difference is you're creating irregular subspace division if you do it like that, because obviously then it's going to depend, the subspaces are going to depend on the geometry of the nature of the geometry of the points. So the question is when you update if that makes a lot of difference. I think it probably doesn't. Because the relationship between the expansion of the tree and the points is going to be based on the nature of the whatever node you put first, the relationship between the nodes from the original subspace. So it might be like, the only thing that might happen is that the tree is going to be very imbalanced, because it can be like the case that on the first subdivision you create a disproportional space. Because let's say like you have one point at one extreme of the geometry, like you have 2 points at the extreme of the geometry. So you create a very small subspace in the beginning, which means that on all the other iterations, you're always going to expand to the left of the tree, for example, because the left space is bigger. So it's just more likely that the other ones are going to fit into the same thing. But I think it doesn't matter that much. So if you can always, hey, what's up? So if I can always guarantee that the subdivision of the space is going to split the space based on the 2 different nodes, then I think I can return there. So here, like the way that I'm thinking about it, so this will make the subspace 0 to be a body, which is going to contain, oh, this is not the body actually, it's the current, yeah. So here it would be different because it's the current node. I'm just pushing the node to the mass, to the subspace 0. Or total mass. Right. Yeah, I think that I can do this because if it is a body, then it is a leaf node. So the total mass is always going to be the mass of the body that existed here. As if I want to be, like, if I want to be sure, I can just do current space body mass. Just because why not? So I'm updating the subspace should be, I'm moving the body that was at this space to the subspace because it has the points. And then because this one has a point, it automatically means that the other subspace is for the position, for the new position. So current nodes, you would be basically copying this stuff. The only difference is because on this one is going to update should be the other thing. This would be the body mass, the body position. The biggest concern I have with this stuff is that it can be the case that there's something wrong here. So I'm not 100% sure if I'm doing it in a way that makes sense. But this is the way that I imagine it. So I'm banking on the fact that I'm going to be able to create a function that divides the space based on the 2 points, but I think that's possible there based on the ChatGPT response. Unless you have a situation where it's exactly the same position for the 2 bodies, which would be an edge case. So I can check for this here as well. So I can check if they both have the same position. And then just do RNG and then put each one. But it's then how do you divide the space? That's the question. I can divide right on the position and then just RNG to put each one on. Or I can, because the position only matters for the center of mass, because that's what's going to be used for the calculation. So I can just RNG, so I can split in any way if they have the same position. Or probably use the same function and then just RNG which one. Or actually, it's always going to be, like the first one is always going to be the one that the current body is going to be at, because it's the first one that I'm checking. So if they have... Yeah, but if I split, then it's not going to be inside. So I guess if they have the same position, I can just bump the one of the positions of the nodes, the current node. So the node that was the body here, I just check to see if they are the same. And yeah, so I just do this because it doesn't matter that much. Just gonna be an approximation because the relevancy of the position is just the calculation of the center of mass, I think. So if the body is on the thing, then the subspace 1 is gonna be for the new body. Position body mass, and then I do the same thing for the other case. But the other way around. And I think on both of them, I just return. So the only recursion is when you have and I don't think I need to update the center of mass for this one because it's gonna update on the previous. Oh, I need to update the center of mass of the current node because I'm moving this. So on here, after I just call the function twice, I think. I don't need to, yeah, I just need to update with the new one because it's already gonna have the other one. So new body. Body mass. Current nodes, body position, body mass. Current node. Oh, it's body position. I hear the same thing. Because I'm creating, so the previous node, like the current node, in this case is a body. So I'm updating, I'm creating the children on this function and splitting the body, splitting the space of the current node based on the new position and the body's position. Then I'm checking to see which subspace the current body of this node would fit. And depending which one it is, I just update that subspace should represent the new body. Then I update the other subspace because it automatically means that the other one's gonna be on the other subspace. And then I just update the body of mass with one of the current node, which was this space here because now it's gonna become a subspace. So it already contains the information of the previous body, because that, yeah, you hold it that, and then you just and then here, yeah, then here I update this information. Yeah. So I'm just updating the value with the new child, which is going to be the new body that is being added as a subspace. Then after that, I just make false, because this is no longer a body. And just delete the pointer. So this is probably, so the only situation where I add, let me see, after you add the roots node and you have the first disputes, and you're gonna have the parents is gonna be a subspace. There's gonna be a space that's gonna have two bodies as children, which means it's gonna call here, and this is not gonna be a null pointer, which means it's gonna update the center of mass with the new position, because it knows for sure that's gonna be as a child. And then it's just gonna, depending which one it fits, it's gonna call again. And then once it calls again, it hits this position because the child is gonna be body, and then it's gonna subdivide the space and update the tree by putting, so it's just pushing the bodies down. I think this is correct, probably. So the main thing that I have to make sure is that this function here subdivides the space correctly. So here would be node space, node space. Create subspace based on new position. If node is a body, take the true positions in consideration. Make sure subspaces are always. I think I don't need this max here, because the A and B already has. It already has a size. No, yeah, it should be a node space, because node space is the A and BB. Whatever. So this is calling from the nodes. So minimum, maximum. I'm just gonna trust ChatGPT on this, because it's kind of annoying. If it doesn't work, then I think about it. What is position 1? Oh, it's position 1 is the first position. Position 2 is the new. So the first position is body. Actually, Yeah, this is another problem that I have to think about, is the memory. It's gonna be annoying. I'm just gonna use memory for now. Hey, what's up? I'm thinking about whether or not I need the condition here. Because the goal is just to create the two different trees. So I think I don't need to put the condition. I'm just gonna do it without the condition. AAB2 is a subspace. It's AA and BB stands for axis aligned bounding box. So it's just a box in 3 dimensions. And AAB1 is one box. It's like a subspace from a space. And AAB2 is the other subspace. So this function is supposed to, I'm not sure if it's gonna work, but it's supposed to divide one space into 2 subspaces, and then initialize the 2 children of the current node. Should be based on the subspaces. Yeah, if you're gonna use as a scripting language, then yes. But I'm creating on the source code. So if you change the source code, then you can do C++. You can either create new modules, or you can create a GD extension. And what I'm doing now is a module. Oh, so the other thing, so it might be better if I delete. Not really sure if it's necessary. So delete here. No, because it doesn't make sense because it's still gonna have the. I'm just gonna change the values. So I think it doesn't make sense to delete because it's gonna be automatically handled, I think. But maybe in the end, I think maybe on the destructor of the graph 3D, I delete the tree. Yeah, I did this yesterday. To try to clarify how to create this function here. And here I'm not really sure. So here I would have to do the same thing if I do menu. I'm gonna ask ChatGPT. The problem is if you're gonna, yeah, this is the issue. I think both I'm gonna have to inherit from objects if I want to use that. And I think that's if you inherit from object, the class has to have a constructor that doesn't accept any arguments. Should make it more annoying, but I guess it's the same thing actually, because all I have to do is just create a function after the constructor and then initialize the value outside, but it's kind of annoying, so. I think everybody uses ChatGPT, but there's so many different large language models nowadays that I think probably people use other ones as well. I was thinking about checking out the other ones, but I didn't have time yet, but maybe at some point. But I think it's pretty much everything is just the same. I also use Perplexity sometimes, because it's just the easiest, Perplexity and ChatGPT so far. I have been using C++. I don't know, I started learning programming around 4 years ago, and I think around 2 years ago I learned C++, the basics. But I think a couple of months or 1 year probably that I've been trying to build stuff on C++. Yeah, Mistral is open source. Then you have Llama as well. But the problem with Mistral and Llama is that you either need to download some other third-party library or application, so you're able to interface with it, or you need to download the source code, and then you need to create the code to communicate with the weights. So it's just too much work, I think, right now. This is the thing that is gonna be annoying. I'm just gonna do it like this, I think. So it's probably not 100% correct, but I think it's good enough. And I'm gonna see if I'm gonna test to see if I can do this without the bind method, or maybe I'm just gonna put here in the later I'll subscribe the functions probably. I learned C++ on Code Academy, I think, on the website. They have a free course for C++, then I read a book. And there is the best channel that I found is from Jason Turner. I watched, I think, all of his videos. There's like more than 400 videos. And I watched everything on 3x speed. And then I read, I think, probably 17 books with text-to-speech, also on 3x. This guy here. But the books is not necessary. So I think I made a list some time ago, and I think I showed on stream, I don't remember when, of the best books. So Jason Turner has a book that is very short, which is probably one of the best, because on the book he puts a bunch of resources to look, which has other videos and stuff like that. And then there's another 2 books that I found. I think it's Kenneth something, a book about pointers. So Kenneth Riff or something like that. It's also the best book. But I still am not very good with C++. I'm still learning, obviously. So, and I think for the more advanced stuff, the only way to figure out is just building stuff, because it's kind of hard to find resources talking about it. Which is gonna be dealing with references and deduction of types on pointers and class abstraction, stuff like that. Those are usually the stuff that is more confusing to understand. And like templated programming is very annoying. So let me see. So I'm gonna try to build. I'm gonna put that on graph 3, graph 2D, and try to build and see. It's obviously like the tricky thing is that there can be a bunch of things that are wrong. So I'm gonna put inside of the this after you create the graph. I just call create barn set tree. I have to include here. Barn set solver. And here is gonna so nodes minimum maximum. This is another thing I have to do now. So every time I have to change the functions there. Yeah, there isn't anything that I can do with the microphone. So sometimes it's because of the connection. I'm trying to avoid touching now, but a lot of the times it just starts breaking or it becomes a lot worse. And there's no way for me to know that it fucked up. I looked for stuff to see how can I hear myself on OBS, but I couldn't find anything, and didn't want to spend a bunch of time thinking about it. So unfortunately, there's nothing I can do when it starts breaking. So here, what I'm gonna have to do is on this one, I have to. So I think I have to create a function that is gonna. So I'm gonna ask ChatGPT, obviously, because it's easier. So maybe I start this one. I start both as 0. Not sure if I can do it like this. Then we're gonna ask ChatGPT, how can I create a function? Not sure if it's gonna understand like this. I have Codium because it's open source, so I was trying to move. So I try to use Codium more, because open source. But Codium doesn't allow you to use the debugger. I think it's because of some licensing thing. So I was gonna move entirely to Codium, but I think I have to use VS Code for now. So that's why I have to. Isn't it normal to be like one day I was just so someone was asking if how to use ChatGPT without logging. One day I was just loading ChatGPT and it didn't ask me to sign in, so I just start using like that. But I don't remember. Because before I used to log in. I still think that they probably use your data to train AI anyway, but it like everyone does that. YouTube is probably doing that. Everyone's doing that probably. So there isn't a way to get away from it. So I think it doesn't matter that much. I don't remember. It's been a long time probably because I always like when I initialize the browser, I always initialize with the previous steps. So, but it does refresh. Like is not is not new. I think it's because of the caching. So like, a lot of the times in Perplexity all the time as well. So it does refresh the page. So it's not like it is as if it had the like previous version. I think it's just a recent thing that they did. Because before you were required to sign in, I think. And then at some point they changed this, but I'm not really sure if everyone's like that or not. I'm just gonna copy this because I don't want to think about it. It's probably right, so it doesn't matter. So now it should be. So obviously I'm gonna call this every time that's So I'm gonna have to create the functions that update the positions as well. But at first, the problem is that there isn't a way to test, I think, without building the update forces first. Because on the update, and then I'm gonna have to think about, I think I'm gonna, so I'm going to do first in 2 steps like it was the other one. And then if it works, then I'll think about whether or not it's worth it. Should try to think about how to do everything on the same step. Or like build the update forces based on the tree structure instead of having to traverse, having to go through all the nodes of the graph, and then calculating the forces against the tree by traversing the tree and analyzing the threshold. But I think that I have to see if it's gonna compile now. So, and then later after I do this, then I have to think about. So I'm gonna create a function to update the node position. Probably gonna create 2 different functions. One to update all, maybe just one node. It makes more sense. So I'm gonna do it on the. It should be on the node. I think it makes more sense to be on the node. But if it is on the node, it's kind of annoying. It has to be on the graph tree. Oh, so this is the thing, it's not returning anything, so it should return roots, yeah. And here should be a pointer. So I should update later because I need to update the positions from the graph 3D, I think. Because every time that I update the position of the nodes, I need to update the position of the edges as well. And I'm gonna have to update the minimum and maximum as well, I think. So inside of the function of the graph 3D, I wrap everything. So I need to do this outside, I think, of this one. So this one just initializes the tree, then I use this tree somewhere else, I think. Oh, actually, wrong place. So after I build the graph, yeah, I don't know, so create the tree. Or maybe I should have, I think I should probably have on the class, the pointer. Yeah, that's probably, it makes more sense. Hey, what's up? So either, I think there are 2 different approaches. One, this part I'm gonna have to think about, but probably in the beginning, what I'm gonna do is just create a function inside of the barn set tree. Here, that is gonna take 1 node, It's gonna take one body and then it's gonna calculate the force based on the body by traversing the tree. It's probably gonna be similar to that node function. And then it's just gonna change the state of the node based on whatever the calculation is. Then after I do that, I'm going to update the positions of the nodes from the graph by calling a function that I put on the graph that is gonna use the velocity and force for the node to update its position, and then I update the edges as well. So I also have to create a I'm probably gonna do so. I have to look into the other project as well, I think. To think about to remember how I did on the previous one. So okay, man. I see you. Yeah, so I'm just gonna put a comment here so I remember. It's gonna be probably node ID. The problem is, how do I know the address? So for this, I have to remember on the other one, I think. It's probably gonna be a vector of graph address 3D. So hash map means but I don't remember how I created this on the other. Because I think that this is the best way to update the node's position. Because you need to update the nodes and the edges each time. I think for each, so like you move over the hash map, then for each node you update the force based on the barn set, I think. Then after that you update the position and the edges. You loop over the edges for each node. So it's an nested loop. And then each time, that's maybe it doesn't make sense. Maybe I don't need that. So I can just loop over the nodes, then update the forces and update the position. Then after, update the edges. So let me, let's see if it compiles. I think this is the biggest problem with this, is that I can see an easy way to like do something and then test and then do and continue. Like I have to do everything and then test later, which is kind of annoying. probably graph. I'm just gonna do, yeah, but if I do objects, maybe compliance. I'm gonna try object first, if it compliance. Maybe it's because it has to be from the graph node, really. I mean, it's probably easier to just put, yeah, but if I put outside, it might fuck up something else. So the other problem is this thing here. This is probably the calculation that is the issue. Not sure if like this or like this. So let me see now. Hmm. Oh fuck. It's kind of annoying because the macro returns an error. Don't remember. Or- So this problem comes from the... It's weird because it's not saying there, but it's coming from the variant type, the conversion between types, because of the type here. So when you subscribe this function to the thing there, I think it fucks up. So here. Well, let me just comment this out, then I'll think about this later, because I'm not really sure. I do remember, I thought, like, if I didn't add this in a property, it wouldn't give me an error. But... maybe if I return as a pointer, it works. Or, like, either return as a pointer, I'm gonna have to make the struct inherit from object, which I don't wanna do. It's kind of annoying. And obviously the other alternative that's much easier, but then it's like it becomes a bunch of stuff. You just should remove this from the inside of the struct and then just change the name of the variables so that they represent force and velocity. I think that's probably the easiest thing to do. I have to think about this now. Because if I build everything based on this, but I guess I can think about this when it after if I get this to compile in the way that it is, then when it gets time to update the forces, I have to think about this. And probably I'm going to simplify, but it's just gonna take a bunch of work to redo everything. But I'm probably gonna simplify because it's just easier to think about. So what I'm gonna do is just change these variables here so that they are outside, and just change the name for so like it's force x, force y, and velocity x, y, and whatever. And then I can have the options like to do like multiple different functions for setting the particular values separately, and then also a function that has sets all of them. Subspace as points. I kind of, yeah, like if I'm able to compile, I think I'm just going to stop, because it's going to be very annoying, and I'm going to have to spend a bunch of time thinking about it. But probably what I'm going to do is just a simple way first. Try the simple, like the biggest problem with this, like I said, is that I have to finish everything, so I'm able to test on the thing. Because I can only test after the moment that I can update the forces. So it's going to be annoying if like it gets to that point and there's an error, but it compiles, because it's going to be difficult to know where the error is coming from. But obviously, I think it like makes a lot more sense to just do stuff and then try to iterate faster to find the errors. But probably what I'm going to do is just after, if I find a way to compile, I just change the values here so that it's separate things. Then I'm going to create both functions on this. Actually, from this one, I don't need to create a function to set the position because it already exists from the node 3D that the class inherits from. And this is the reason why I didn't put here, because it doesn't make sense to redo. I guess I feel it's kind of redundant, but maybe it's probably better. It might be better to do this, but actually not, because the position comes from the node 3D, which is from the inheritance, and not the sphere. If the position was coming from the sphere, which is a mesh from the mesh instance 3D, then I think it would be worth it to create another function in this class to just wrap the set position from the other one. But I think since it's coming from the node 3D, it doesn't make sense. So, but maybe it makes sense because I have to update the other stuff. But I think for updating the updating the position based on the forces, I have to look into the other project to see how they do it here. And I'm probably gonna create a function on the graph 3D that is gonna, based on the, actually it should be on the tree there. So the function on the tree that updates the force, I'm gonna pass the node, and it's gonna be the node and the root of the tree. Then it traverses the tree, which I think is the simplest way possible, and then it updates the force based on the threshold, which is the, I'm gonna use the size of the A and B divided by the distance of the center of mass of the current node and the node that is the force is being applied to. But I'm gonna clarify here. And then I'm gonna use the functions from the node, I think. So I do have, yeah, probably just create the functions that update the forces and update the position here, probably. Because actually, yeah, update the position based on the forces outside, I think. I can do both, obviously. But I think that the first you update the values of the force and velocity of each node based on the tree. Then I have to think about, I'm gonna look into the projects, into the front-end code to see how it's doing, to update the positions of the nodes and the edges. And I'm gonna create a function in the graph 3D to do that based on the velocity and force of each node. So from the barn set tree parts, I think I only update the force and velocity of each node. But maybe, because then it's kind of redundant. Like the thing that I'm thinking about is that obviously is much better if I update everything at one time. So like as I traverse the tree for each node, I update the force, velocity, the position as well, and the edges at the same time, I think. I think so the question to clarify again is the relationship between the edges and the, because I might have to change the classes. So the relationship between the edges and the nodes. Because probably the best way to do it is probably to update everything related to the node as you traverse the tree. So update the force, velocity, and position. And then just loop over the edges outside and update the edges. Yeah. side that I have to return as well. Because this one, it doesn't matter because it has to, it's gonna call again, so it doesn't matter. And the problem is, like I said before, like there's no way to know if it's working or not, even if it compiles. So I'm just gonna review the add node because that's the biggest one that might be wrong, I think. So if this one is correct, then I think that's the other one's probably gonna be easier to update the forces because it's just doing that first search and then checking each node. So the thing that I have to clarify is how does it work? Like if you, I think you traverse the whole tree and then you apply the force for each node, regardless of whether or not it's a space or a body. The only difference is that, like, and you're always going to do the same calculation. Yeah, so the difference is the threshold. So the search space of the tree is determined by the threshold theta, which is the relationship between the size of the box and the distance from the center of mass of that the subspace has with the node. So I think that true update force is probably really easy to do. You just do that first search and then you compare at each step the theta. So probably the other thing that I can do here is to also add the theta here. Yeah, I have to add the theta on each node. No, but the theta. Maybe the theta makes more sense to do it outside because I have the values, so it doesn't matter anymore. You can get, so I get the size from the node space and then I get the magnitude of the size, I think. So like it's just, it doesn't matter that much the specifics, but I think it's just arbitrary, this part of the theta. Because obviously you can just change the range if it doesn't look very right. So like you can do, as long as it's consistent between subspaces, so I can always get the magnitude of the size, just the length of the size, the subspace, and divide that by the distance of the nodes that I'm comparing. I'm updating the force and the center of mass. Yeah, so, and this is gonna be, and then I add that to the force and the velocity. So I think that it should be very easy to do after. So the biggest place where you can be wrong is that tree node. So I'm gonna review this, then I'm going to spend some time reading the update force on this code here. And after that, I'm going to, after I'm able to implement Barnsat, I'm also gonna have to finish implementing the other solvers. But I think the other ones are a lot easier. It's just like additional stuff to take into consideration the force on the spring and the force of gravity of each node. Because it's based on the way that VGS works. So it's basically this three here. But the Barnsat's the most annoying one to implement. So the other ones are probably gonna be a lot easier, I think. So now I'm gonna look into the update force of the other code to see. But I'm gonna review this, look into the other one, then I'm gonna stop streaming. And I think off stream, I'm just gonna update the functions here. So like just to simplify, so I don't have to think about this annoying thing about the class DB thing. So I'm gonna have to spend a bunch of time like creating a bunch of different functions to update each value of the thing. And then I'm gonna create other functions that update all of them like at the same time. And then inside of the tree, I'm just gonna, when I update the forces, I'm just gonna use the functions that are created here to update the state of the nodes. And then based on the state of the nodes, based on the velocity, and so probably on when you update, you can't really update the position. You have to update the position outside. So as you traverse the tree, you just update the force and velocity of the node. Then after you traverse the entire tree for the nodes, outside of the function on the Barnsat's tree, After you call the function on the branch set tree, you call the function from the node to update its position based on the force. So I'm probably gonna have to put, I'm gonna create another function on this one that updates its position based on the current velocity and force of the node. And then I loop outside on the graph 3D and call the function to update the force based on the branch set tree for each time. So I just do another loop here. Then after I do that, I loop over all the edges, and then I just update the positions of the edges. So the main thing that I'm not really sure, that I don't remember at all, which I might have to change, is the connection here. And I think that's the reason why I use the node map on the other ones, because it's easier to create the link between the edge and the nodes. So like I'm initializing the edge, so I have the, yeah, this is the problem, because I need to have the ID of the source and the target to update the edge. So I think the easiest way is probably choose the node map. I think the best way that I've seen is just using adjacency lists, but then it's like confusing. I think the Boost library uses adjacency lists, and then it puts information based on the values of the matrix. And the adjacency list is just rows and columns that have the IDs of the nodes, and then the values are Boolean values that represent whether or not the node has it's connected with the other one. So if it's 0, it's not connected. If it's 1, it's connected. So based on that adjacency list, you can extract information. You can add extra information if the node has an edge outside. But I think it's just too confusing. So it's not very worth it, I think. But this way that I'm doing is probably a lot easier to understand. But it's probably not that fast, I think. As fast as it would be for an adjacency list. But maybe it's not even possible. I think it's probably possible, but it's just more annoying to implement adjacency list, because you need to have the other stuff as well. Yeah, so I think the way that I did on the other ones is that as I update the node position, I look into the node map, and then I update the edges based on the position of the source or target. So I have to, on the graph edge 3D, I need to figure out, like, I need to create a functions that's based on the check to see if the ID that I'm passing is from the source or the target. And then either one, it just updates the edge position based on the position that was moved. So that way I update the edge each time that I change the node. I think that's the easiest way to do it. So I'm just gonna write here. But maybe it's better to, because then I don't have to draw twice. I think it's better to update the edge after updating the two positions. So yeah, it's probably better to. So yeah, I think that's better to update the edge after updating the two positions. So draw the edge only once each frame after the nodes change position. But then I have to think about how to. So great. Yeah, so the function receives source ID and targets ID. in target position again. So the thing that is kind of confusing is to think about what is the best way and where should I put a data structure that is going to allow me to connect. Because the way that I did here, I only have one node, so I don't have the connection of the like if I update all the nodes positions, then I can't loop over all the edges and update both, because I need to know the source and the target, obviously. But yeah, I have the IDs on the thing. So I think on the graph edge 3D, I need to create a function that gets the position based on the ID. So I need to connect them. That's probably the easiest way. So I create a function on the No, that's why I need the node map. Yeah, that's why I use the node map. So the node map, you use from the edge you get the position. Yeah. So I'm not really sure if I need. So I need something that allows me to update the source and target position on the edge based on the IDs of the nodes. So this makes me think that it's probably better to save the nodes as a map instead of a vector. I think it's probably better to, instead of doing the nodes on a vector, I do it on a map, and then the key on the map represents the ID of the node. That makes more sense. Because then I can use the ID from the edge to get the node position. I'll think about this stuff later. So I'm just gonna go over the function again there. Because it is kind of confusing. I have to spend time thinking about what is the best way. Because there's a bunch of different ways to organize. And it's gonna depend on the relationship between the classes there, on the graph and the edge, and the graph 3D. On what is the best way to update everything with the minimum amount of stuff you do twice. So obviously I want to avoid looping over the graph as much as possible. So ideally I could do everything on one loop. That's probably unlikely. So I have to see what is the best separation of the data structures, because it's going to influence on the way you structure the function to update each node inside of the tree. So I'm just going to look into this one. So we'll start from here. So here it creates. So each time that I add a node on the graph 3D, I'm going to check to see if the position of the graph is smaller than the minimum vertex that already exists. It's going to be 0 to begin with, or if it's greater based on this. Which I just got from ChatGPT, which could be wrong. But I think it is correct because it's just checking like bigger, smaller. So yeah. And Yeah, so I have the minimum and maximum. So from the minimum and maximum, you can get the size, which is just the vector from the minimum and maximum, which is the diagonal of the space. So this first space here that I create is just a space that encapsulates the geometry based on the minimum and maximum vertex from the geometry. Then I use this space to create a pointer through the root of the tree, which is the space that encapsulates the entire geometry, which is the entire graph. Then I'm looping over each node of the graph and adding each one to the tree based on the space. So here I got the position and the mass. So this case is when the space is, when the current node is a space, which means it's not a body, which is going to be the first situation on the roots. And by default, all of them are not going to have children. So it's going to fall into this scenario here the first time on the root. And it's just going to update the root node should be a body instead of a space based on this stuff here. So on the next node that it adds is not going to be a space anymore, it's going to be a body. And whenever you have two different bodies that want to be on the same space, you have to subdivide the space again. And here I'm subdividing the space based on the two positions. So I'm betting that, because I'm not 100% sure if this function is going to work, because I got from ChatGPT and I didn't check to see if it makes sense. But I'm going to do that off stream, and then obviously I'm going to test sometimes. And this is one of the fundamental things that I'm not really sure, because I think that this is one thing that I'm doing fundamentally different here than from the article. Because I think that usually the way that this is done, as far as I understand, is that every time you have a subdivision of the space, you're always going to divide by the same amount. So if you're doing with the octree tree, for example, you have the initial first space, and then from that first space, you're going to create 8 different cubes that subdivide the space into 8 children. That's how you do it on 3 dimensions based on the article, the logic from the article, I think. But the way that I'm thinking about it is that I'm doing a binary tree, so I'm just subdividing the space in half each time. And the difference is that it just increases the size of the tree. So it's a trade-off of memory and speed. So the less nodes you have, the more subdivisions you're going to do on space, so the bigger the tree is going to be. And yeah, but then I think it becomes simpler to think about. But and also the difference is that I'm thinking about not trying to divide the space always in the same way, because I think it makes it harder, but maybe it's better if you do it that way. I'm not really sure. So I'm gonna have to spend time thinking about this, but I think that it makes more sense to do the subdivision of the space based on the position you want to add and the position you had before as the body. Because if you're able to guarantee that each position is going to be on... I have to finish doing this here as well, which is the check to see if the position is the same. But I'll do this later. So, but if it's the same, it's just going to be the same logic. I'm just going to change the current body position to add like slightly to the right, for example. And then the set subspaces function is going to guarantee that based on the initial space, the space for the children is going to be based on the distance between the 2 different nodes, I think, which is the node that existed on that space and the current node being added. And this is going to guarantee that the subdivision always creates 2 subspaces that is going to be for each node that you're adding. So there's always one subdivision for each iteration if there is a dispute on the space. Yeah, and I'm going to have to spend time looking into this function. So it creates the children for the current space based on the 2 points. And then I check to see if in which subspace the current body is going to be. Then depending which one it is, I just pass that body as a child. So just pass the body down the tree and updates, and then I put the new body on the new position, which is going to be the other subspace. Because of the subdivision is, like I said, it already takes into consideration that it's going to be like a certain thing that if the current body fits on the subspace 0, then it automatically means that the new body has to fit on the subspace 1 because of the way you're subdividing here. And then I update the center of mass and the mass of the current one should take into consideration the new body being added, because the state of the current node already had the previous body before the dispute. I think that's correct. Well, I'm not sure. So the only situation where there's going to be a recursion is when you have a subspace that has children, which would be like the third iteration, I think. So you can imagine that you have the root, which is now a subspace, and then you have two children, which are the two different bodies that were added. So this space is split in half based on the two positions. You're going to have a situation where this is not going to be no pointer, and it's going to be a subspace. So we're going to update the center of mass with the new body, because you know the new body is going to be a child of the current subspace. And then you check to see in which position does the new body should be implemented falls into. I guess here I also would need to check. Maybe not, actually. So here, like, think about whether or not should check. Just see. So I think what I can do is just call the function of the intersection there on the box, I think. Just see if the subdivision, if the new point being added falls into the plane that makes up the subdivision of the spaces. Because then obviously if it does, that means that the points would fit in either one of the things. So this might be very problematic, I think. Because like if I have to avoid trying to update the split, because then you have to think about rebalance, like updating the entire tree, which doesn't make a lot of sense. So I think that the easiest way to deal with this is just by shifting. So I compare, I check to see if the current position being added falls exactly in the plane of the subdivision. So like, and this would be the case. So I can check to see if it fits both on the subspace 0 and on the subspace 1, then is the situation where the points are on the plane of the subdivision. So if that's the case, then you just change slightly the position and then you check again, and then you do the recursion. Because that would be like the RNG. And it doesn't matter because the positions is just used for the center of mass and the calculation. So like it's roughly going to be the same, so it doesn't matter that much. It's like rolling the RNG in case you have a superposition of nodes. The other thing I can do is just create another function that it just keeps iterating based on the delta, just the small difference, to see. But I think that like by the moment you move, it's already going to have a distance between the planes, so it's going to fit on either one of the boxes. So I think that this does guarantee that it's gonna traverse either left or right whenever you have a subspace, and it updates the thing. And the next time, if you have multiple levels that have subspaces, you're just gonna keep recursing and updating each center of mass of each one until it gets to a leaf, which is gonna be a body. So if it gets to a leaf that is not a body, then it just updates the thing and it ends the function. And if it gets to the leaf that is a body, that means that that node has to fit on the space of the body. Because otherwise you would be to the other, you would go to the other points, to the other subspace. So yeah, it automatically means that this condition was correct, or this one, and it was, that's other subspace is a body, which means it's going to fall here, which is going to update it's going to subdivide the current space and updates its value so that it's not a body anymore and it's a subspace, and update center of mass, and then you finish the function because I'm just moving the body to either leave of the node and putting the other node on the other place. So the binary tree is always going to contain, I think, as children, either one body or two bodies. Yeah, I think that this makes sense. So obviously I'm going to have to think about the nuances of this and then test later. It's going to be very annoying if it gets to the point and I realize there's something wrong. And then after I do all of this, then it might be possible to do several optimizations that I was thinking about, but I'm not pretty sure if it's going to be worth it to invest the time. But one thing that I'm thinking about is that the amount of children is directly correlated with the space subdivisions, as I said. So I think that the structure of the function that determines the subspaces is a reflection of the amount of children that the tree has, because it's a fractal pattern, which is directly correlated with the geometry. So one thing that's I think would be overly complicated, but it might be possible. I'm not really sure if people have done this already. Probably they have, but you could create a tree that has an arbitrary amount of children, and then based on the data of the geometry, it figures out what is the optimal amount of subdivisions, and based on the structure of the function. Not sure if that's possible. Oh, this is another thing that I was thinking about. So this is where I think the optimizations can happen, and also for updating the forces, because you can create a data structure outside as well that keeps track of the history. So so one thing that I was thinking about, like to update the forces without having to traverse the tree each time, is you have to figure out what are all the bodies, where are all the bodies on the tree, and yeah, but I guess it's going to depend on the center of mass as well. But I think if you use another data structure, it might be possible to just calculate or create a function or something that uses the other data structure to calculate the overall amount of force on each node without having to traverse the tree each time. So I think that those are the two main things that I'm thinking about, whether or not it's worth it to implement. So the first one, which I think that it might be relatively easier, you should just use the state of the tree to update the force on each node without having to loop over all the nodes outside. Just based on the state of the tree itself and another data structure you use. Based on the control flow you put here, you update the other data structure that you would automatically allow you to update everything. Because the tree has an instance of the nodes you want to update, which is the body. So obviously you can put functionality that is going to update the body automatically without having to loop over the graph. I think that would be better. And the other possible optimization, which I think is just a lot more difficult, is the relationship between the amount of children that the tree has and the structure of the function that creates the division of the space. Because it's going to be a correlation of the complexity of the geometry and the optimal geometrical space. So like it's kind of like a space and counter space thing, where the shape of the geometry determines the optimal shape of the space subdivision to optimize the amount of children you need to have to determine the optimal distribution of size and speed for the data structure to calculate to update the forces. But I think that's that one is probably like way overly complicated, I think. So I'm just gonna spend time on this one now. The problem here is that I think that he did it on I'm not really sure if he's not really traversing. I think he isn't doing that first search, probably breadth first search because of the queue. So I think it's a different way to think about it. The current node is a leaf node and it is not source body. Calculate the force exerted by the current node and body. So monitor the body is not force. So this comes from, so you just multiply it by the gravity. Yeah, it's just calculating the force based on the weight. So gravity times mass times the center of mass divided by the cube of the radius. And then it just accumulates the force here. The ratio SR. Yeah, so I think this condition is whenever you reach the end of the tree. So you're comparing two nodes, this condition here. So you're just adding the force of that node based on its mass to the force that you want to calculate on the body. So this Fx is probably, so like for each node you want to calculate the force, you increase these values here based on the condition here. So like this is probably doing breadth first search on the tree. And then for the leaf nodes are the ones that have the body, you just update the amount of the force based on that, the body velocity, which is the weight times the mass divided by this R cube here, which is probably some simplification that they did. So you're just accumulating everything on the force. And then this situation is where you have a center of mass node. So on this one, you're going to calculate, you're going to see if the threshold was met, which is the theta threshold that is used to do the simplification of the overall force, the final force. So you don't have to traverse until you get to all the nodes. So if the other nodes are very far away, then it allows you to simplify the calculation, because instead of using the node position and mass of each node, you just accumulate all the nodes into their center of mass, and you calculate the force based on the center of mass according to the simplification. So it's checking for the theta here, and then it updates. And then the final value is going to be stored on fx, fy, and fz, I think. Otherwise, when the procedure, so if the threshold was a met, it just keeps recursing either until it finds the leaf or until the threshold is met, I think. So it's just doing breadth first search and updating the force. And then it just adds the force to the body. So it's not that difficult to understand, actually. It's very easy. The force updates very easy. But it's going to be hard if I want to try to optimize, I think, in the way that I said there. Because then I'm going to have to think about... Because the issue with... So like the simplest way that you can do it, I think, is like... For every time that you add a new body to the tree, you just keep track of the body on a different data structure outside. Maybe you can do that. It doesn't... And the problem is that you would have to update each time. But maybe at the end, after you create the whole tree, you just traverse the tree once, and then you create another data structure to store the gradient of the data on the tree. And then based on the gradient, but it depends on the distance, that's the problem for each node. But I think that there probably is something like that. But I'm probably going to do the simplest way first. But I think I'm going to stop streaming here, and I'm just going to update. I'm going to do this annoying stuff of changing the structure so that I'm able to update each one without having to worry about this stuff about the class DB. Then once I finish doing these functions, then I'm going to think about, I'm going to start working on the I have to add this other data structure that is going to allow me to update the edge. And I have to think about what is the best way to update the positions edges with the minimum amount of loops possible. Then once I do everything, then I work. Once I think about all these functions and data structures and I have everything, then I finish creating the update force function on the tree. And then I put everything on the graph 3D, and then I'm gonna open on the editor and see if it's working. So if it's moving the thing. So the first step is gonna be to create the tree here. You add the nodes and the edges, then you create the tree based on the nodes, and then you loop over the nodes, then you update the positions based on the force of the tree, and then you update the edges based on the new positions of the nodes. And I'm gonna put this on each frame as well. So I think probably to update the forces, I'm probably gonna move these functions to another part, to this part here, or the physics process, because the physics process or the process are the switch statements that run every frame. So it's on either on the notification process or the notification physics process. So I'm going to create another function that creates the tree and update the forces each frame, and then updates the position of everything each frame, and this should create the solver. And the last step is to replace everything replace the variables that are dependent on the Barnset parameters. Yeah, so I'm probably gonna have to change the functions as well so that they receive variables from the Barnsets. But this is probably only gonna be on the forces, I think. So I'm gonna stop here, and next time I'm gonna continue to do this. And if I do everything upstream, then I'm just gonna explain what I did.